Hi, hello, dear students. Welcome to my session on carbonyl compounds. In this carbonyl compound session, I would like to give you an explanation based on the preparation of carbonyl compounds, aldehydes, and ketones from particularly hydrocarbons. As I said earlier in the last session, also there are some hydrocarbons I have taken. Like alkyne, I have taken triple bonded compounds. From that, how we could able to prepare aldehydes and ketones, I have discussed. Now, in this session, I would like to explain the preparation of benzaldehyde, preparation of benzaldehyde in this session, as well as some additional information if it is required. Okay, let us start this section. Dear students, this is about the preparation of benzaldehyde. This is about preparation of benzaldehyde. Preparation of, I can say, aldehyde, particularly aromatic aldehyde. Especially this is for benzaldehyde, I am explaining. Let us see how we can prepare the benzaldehyde. Actually, this benzaldehyde can be prepared from alkyl benzenes. So I am taking the idea of alkyl benzene in this one. As you all know, alkyl benzene, let us suppose methyl benzene in this one. A methyl benzene, if you take, nothing but toluene. If you take methyl benzene, so what will happen? Methyl benzene, if you treat with the chlorine, methyl benzene on treatment with the chlorine in the presence of sunlight, or chromium oxide is also oxidizing agent, CrO3, that should be present in acetic anhydride. Acetic anhydride. What happens? That definitely will give. We have a compound that is called as CHCl2, or we can also write that one as YRCH. Acetate ions will write, that is OCOCH3. That is also 2 times will come respectively. So when you use chlorine, you will get CHCl2. When you use acetic anhydride, CrO3, you will get ArCHO, twice. And what will happens in this one? Both these compounds on hydrolysis definitely will give benzaldehyde. So, what is the final point in the discussion is both these compounds on hydrolysis definitely will give aldehyde. What is the expected one is benzaldehyde? Definitely that will come when we have done the process. What is the chemical equation which is required for this process? That is, if you take C6H5CH3 as toluene, methyl benzene, if you treat that one with chromium oxide, sorry, I will write here chromium oxide other side, and I will treat this one with chlorine in the presence of light energy. I will be getting C6H5CHCl2, as I said earlier in the written explanation, and which will be subjected to hydrolysis will get benzaldehyde, that is for nothing but C6H5CHO. Whereas when you have taken chromium oxide, CrO3 in acetic anhydride, chromium oxide, which is present in acetic anhydride, which is actual acetic anhydride is a solvent. Okay. Then we're going to get a diacetate, like I have said earlier here, that is C6H5 CH OOCH3 or OCO CH3 OOCH3 two times. That we'll call it as a geminal diacetate. Yeah, this is nothing but after hydrolysis you will get benzaldehyde.
Now तो जैसे आप आइडिलेट और बाकी
So we will get a geminal diacetate. That's what we call it. This is geminal diacetate. This is geminal diacetate, which will be subjected to hydrolysis. After doing hydrolysis, we will get benzaldehyde, that is C6H5 CHO. Hope you understand how we'll prepare benzaldehyde from toluene or methyl benzene. Okay. So once again, I'll show you the description. You wrote write in the notes, that is methyl benzene on treatment with chlorine or chromium oxide and acetic anhydride, which gives CH2Cl2 group attached to benzene ring, or ArCHOCOCH3 twice respectively, and both the compounds actually said to be undergoing hydrolysis, which gives final product called aldehyde, benzaldehyde. So what is benzaldehyde? That is CH5 CHO. This we will call it as benzaldehyde. Hope you understand. Now, in addition to this one, so in this, we're going to show you how this acetaldehyde is going to be, how this benzaldehyde is going to be obtained. What are the conditions in this reaction? The reaction conditions are quite interesting here. That is, nothing but when you are going to do oxidation process, you are going to do oxidation process, and this oxidation by CrO3 in acetic anhydride, that is CH3CO twice O. Actually, in this method is said to be a better process, I can say, a better method, we can say, than the other one. What we have shown, the other one is chlorination. The other one is chlorination, because the geminal diacetate, whatever obtained, right? Geminal diacetate obtained, which cannot further oxidize, but which will oxidize, but geminal dichloride, gem dichloride, whatever obtained. What is gem dichloride? It is CHCl2 attached to the ring. Further, definitely chlorinates, which can further chlorinated. That is said to be giving a benzene related compound CH5 CCl3. So what is the problem with this one is, if it further undergoes hydrolysis, we will be getting benzoic acid. That is C6H5 CO2H. This is what the problem we are going to face when we prepare the benzaldehyde using this chlorination process. So chlorination process is not suggested. Oxidation by CrO3 and the presence of acetic anhydride solvent is said to be suggested. So moving on to the other kind of the preparation of benzaldehyde from benzene. From benzene also we can prepare. From benzene also we can prepare benzaldehyde. Let me tell about that one. As you all know, an important chemical reaction called Friedel-Crafts reaction. Using that one, you can prepare benzene related carbonyl compound. That process will call it as Friedel-Crafts acylation. Friedel-Crafts acylation of benzene. Friedel-Crafts acylation of benzene. Carbonyl derivatives. Carbonyl derivatives can be synthesized. The process we'll call it as, the method is we'll call it as electrophilic substitution reaction. Electrophilic substitution reaction. In this one, the electrophile obtained is called as acylium electrophile. Electrophile is called as acylium electrophile, which is nothing but RC plus double bond O. This one actually is formed in the mechanism. Is formed during the mechanism. Okay, check it out. Let us check it out, the equation part of this one. Let us check out the equation of preparation of the benzene carbonyl derivative. First of all, we're going to take the benzene, and the benzene will be treated with acetyl chloride, that is CH3COCl, and this will be treated in the presence of Weiss acid, that is anhydrous AlCl3, or any kind of Weiss acid you can take to get the derivative of this carbonyl derivative of this one. So this is nothing but COCH3 attached to benzene ring, nothing but acetophenone, and HCl will be abstracted. This will call it as alkyl substituted compound here, carbonyl compound. Strongly deactivating group is there. And this one, that's why here what is happening, this strongly deactivating group is present over this benzene. To convert this one into nitro related compound, it is easy. So now we'll see the examples of that advancements. That means upgraded version of this equation. That is an example. How we will prepare benzene derivative of carbonyl compounds. Example given to us is convert a benzene related compound aniline toluene into CH5, NOD is present in the para position. First of all, we need to take the two directions of the reaction. First step, I can say the step one. This toluene has to be converted. First of all, this toluene has to be converted into carboxylic acid by treating with a strong oxidizing agent, camphor and stick medium. We'll be getting benzoic acid, right? That is COH attached to benzene, and which will be further subjected to nitration. If you do nitration, you will be getting a meta directing compound in the same way. Meta directing compound, that means the COH is present and NO2 comes at the meta position. Or that you will do the decarboxylation. After that, you will do decarboxylation with soda lime. You will be getting meta nitrobenzene. You will be getting nitrobenzene. You will be getting nitrobenzene. Okay. Suppose if this is treated with benzoyl chloride, H5COCl, in the presence of anhydrous AlCl3, there is no reaction is going to take place. Why? Because strongly deactivating benzene nucleus is NO2, which is not favoring this reaction of acylation. Okay. In the step 2, what you will do here is continues to takes place. In the step 2, we are going to take benzene itself directly, which is treated with the compound obtained. The compound obtained is nothing but COOH attached, NO2 at the meta position, and we're going to treat with the benzene here in the presence of AlCl3. You are going to get the carbonyl derivative in place of carboxylic acid, that is COC6H5, and NO2 is present at the position. So this is what we have obtained from this reaction. So what to understand here is, whenever we want to prepare the benzene derivative carbonyl compounds, make sure that strongly deactivating group is there at on the benzene ring that won't favor the substitution reaction. That time you convert the carboxylic acid of benzene into the carbonyl group of benzene. Okay. So this is the most important point what we have discussed in this line. So dear students, hope you understand this session of preparation of benzene derivatives, carbonyl derivatives of benzene, aromatic compound preparation with one example also. Okay. We'll meet in the next section very shortly to discuss many things in this carbonyl compounds. Okay. Have a nice day. Thank you.